welcome to section 2.1, Efficiency for Real-Time Computing. I'm Piccone, Garbini, and Devine are my co-authors for this book, An Introduction to Real-Time Computing for Mechanical Engineers. Check it out at the MIT Press website and rtcbook.org, the companion website for the book. Real-time computing and efficiency. Periodic real-time tasks. Let's look at an example of a periodic real-time task. A periodic task that must repeat at a rate of 1 kilohertz. In most cases, this implies a deadline of less than 1 millisecond. The task and its subtasks must complete consistently in this duration to avoid failure. Therefore, the task requires a total runtime of less than 1 millisecond. Aperiodic real-time tasks. Aperiodic tasks have similar constraints. Not only must a task start at a specific time, it must also finish by or at a precise moment. Control of timing is affected by the runtime of each task. The shorter this duration, the better. Optimization design considerations. Minimizing runtime is always a consideration for real-time system designers. The cost of fast computer hardware can be weighed against the cost of designing for efficiency, but the benefits of design investment usually outweigh the cost. It is important to avoid premature optimization. A programmer should first write a program that correctly performs its function before attempting to optimize the program by improving efficiency. In this sense, the design process itself should be optimized. Design guideline. Incrementally improve a program from something that works to something that works efficiently. Embedded computing. Embedded computing and resource minimization. An embedded computer is one that is an integral part of some larger system, often an electronic and mechanical system. Embedded computers are not all considered real-time because they may not have strict timing requirements, but most real-time computers are embedded. Examples of embedded computers. A car that has a computer to control the engine. A robot arm that has a computer to control its movements. A dishwasher that has a computer to control the washing cycle. All the computers in the examples above are also real-time computers, with the possible exception of the dishwasher, which may not have strict timing requirements. Embedded computing shares the real-time computing emphasis on design efficiency, and for us it highlights a specific aspect of it, resource minimization. Many embedded systems are reproduced in high volume, and a good portion are battery-powered and portable. Cost per unit, battery consumption, mechanical size, and even weight can be important design considerations. Therefore, efficiency is a critical aspect of real-time system design. The rest of this chapter explores ways to design for efficiency. So we'll pick it up there next time.